Okay, I think you see the full screen. Is it right, Rod?
Yes, good, perfect.
Okay, stop. I forgot something. 1 second. I will switch my camera off. Okay. Once again. Okay, now we can start. Oil consumption. Oil consumption, it's a big discussion on the road, also together with the truck driver, passenger drivers, and also I think when some customer come back to you when you recondition an engine, and some of them they say now I have oil consumption, and this is why I took this presentation together and show you what you can discuss maybe with your customer. And can give them some points in the hand why maybe this engine have now oil consumption, and then it's easier to you when you discuss with your customer. General information first, and then calculation of the oil consumption, and then the case and the influence of the high oil consumption, and the installation of the possibilities of errors. There are 4 points in the presentation, and I will start first with the task of the oil. The oil in the engine, we need it for the lubrication and the reduction friction. Also for the cooling inside, the cooling of the piston, and also for the bearings in the piston pin and so on. This is why we have also the oil in the engine and need it. The sealing effect, what the oil it's bringing on the piston between the piston rings and the surface of the cylinder bore. This is why we have this oil in different viscosities up to the surface and so on. But together with the piston rings, with the surface of the liner, it's the sealing, and also for damping because of the noise. When the piston it's moved from the left to the right side, when the crankshaft it's turning and the convert it goes up and down, piston goes up and down, then we have the piston jump to the left to the right side, and then the oil is also damping the noise, and it's possible much more on a steel piston than on an aluminum piston. The next slides give you an overview about the typology. Here we see again when the piston moves up and down, and the piston ring in the middle of the slide, you see the piston ring and the yellow area, this is the oil. And between the piston ring and the surface of the cylinder bore, we have the oil film. And the oil film must be between the piston rings and the surface of the cylinder bore. When we have missing this oil, then we have directly contact with the cylinder bore, with the piston ring, and then we have a lot of wear. And this is why we need the oil between. We need for the tribology, and this is the same effect what we have when we drive with a car. Sorry, 1 second. When we drive with a car with high speed and there is a lot of water on the road. In slow condition, the wheel it's push the water left and right side, and the wheel have contact with the road. When the speed is higher, and then the water it's on the front of the wheel, and then it's the critical point it's coming when the speed is much more higher. Then we have a high pace. That means the wheel it's lifted up on the water, and then we have between the wheel and the road, we have the water. And this is exactly the same. When the piston it stay, the piston ring contact with the liner. On the left side, the wheel have contact with the road. The water, it's the oil. When we bring the speed up and down the piston slowly, then the wheel jumped up much in how much it's the speed of the piston. The piston ring, it's jumped up on this oil, and then it's moving on this oil film. And this is also the situation when the piston is in the top dead center. The piston, it stay for microsecond, and when they stay, then they don't move it, and then we go back to the first place on the left side on this page. We have contact with the piston ring and on the surface, and this is also why you have on the top dead center, on this area, the piston ring, it's moved from up and down in the top of the position. We have much more wear than on the bottom side. We have much high pressure on the top, and we don't have the speed, and then the piston ring, it's jumped between the oil and have contact with the surface on the liner. This is one example. The same example you can explain it with water skiing. This is the same when you stay, when you drive on the water. I hope you understand what I will say with the typology of the situation of the piston ring in the situation when they moved up and down with the oil film and the surface. Any question up to here? No?
No questions yet.
No questions yet. Up to the piston ring and up to the oil film, these are two components, and the third component is the surface on the cylinder bore. We can have a cast iron cylinder bore, then you see the scratching marks of the honing process and the grooves inside, and this groove, these are the accumulated oil. This is the oil volume. They are inside in the surface and have the clamping effect of the oil on the surface on the liner. This is the grey cast cylinder bore. The next slide gives an overview of the Alusil cylinder bore, Alusil, Locasil, or Silitech for Mercedes. We have also the oil volume, it's staying between the silicon crystal. The black parts are the silicon crystal, and there are, you see, the accumulated oil, it's between the silicon crystal. This is completely different to the grey cast liner, to the grey cast cylinder bore. And also the third one, it's a plasma coating. This is the newest generation, also what you can find in passenger cars, BMW, Mercedes, Volkswagen, Audi, and so on, Porsche. They have this coating cylinder bore inside, and this is another, I would say, completely different overview of the surface. We have now holes inside, and in these holes, in these bubbles in the surface, there is staying the oil and clamping the oil on the surface. When we don't have these bubbles here in this situation of the coating cylinder bore, or this area on the Alusil, Locasil, or Silitech, or the groove inside in the grey cast liner, and when we don't have it, then it's very slippy, and the oil, it's jumped quickly down to the bottom, and then we don't stay the oil between the piston ring and the surface of the cylinder bore. And this is why we need also a roughly surface, the grey cast, in the Alusil, or in the plasma coating cylinder bore. Altogether, the piston ring, the tension of the piston ring, the oil viscosity, and how thick it's the oil film, and also the roughness of the surface. All the three components, this give this typology situation. And when one it's not in the right condition, then we have problem. And then we speak also we can speak about of oil consumption. This can be the result. Any question up to here?
No questions.
Okay.
Thank you.
Then the next step is the calculation of the oil consumption. A lot of people, they speak about oil consumption. When we speak of oil consumption, we will not speak today with oil consumption when we have a leakage on the bottom on the road. We see a oil place. We speak today when oil it's in the oil consumption, when the oil is burning in the combustion chamber. Then we have normally blue smoke on the exhaust pipe. When the customer came and say, oh, I have oil consumption, then you need a right calculation. That means they can become and say, oh, I have oil consumption, X liter to the next oil change. Or the next customer is coming X liter per day, or X% to the fuel consumption, or X liter per 100 or 1000 kilometer. What do you think is the right evaluation of the oil consumption? One, two, three, or four?
No one is going into the chat box.
Okay.
It must be a percentage of fuel consumption, surely. Number 3.
Number 3, that's right. Yep, perfect. Yeah. X liter to the next oil change. I don't know how much is it. How many kilometers or miles they drove. How many hours was the engine runs. Also, per day, I don't know how long and how much they do it in the day. This is right, X% to the fuel consumption, and some cases in the passenger car, we say X liter per 100 or 1000 kilometer. But when we will calculate it exactly how much is oil consumption, then it's the only right information, X liter or X% to the fuel consumption. That means in this situation, we can say exactly in which condition also was run the engine when they will speak about of oil consumption. When they have a very less fuel consumption, then we know it, the engine is not running in very high load condition. The manufacturing data, it's coming not from us, this is coming from OE, from Mercedes, MAN, VW, Audi, and so on. They say 0.1 to 0.5% of the fuel consumption can be the oil consumption. In this calculation, you see when we have a calculation, passenger car, 10 liter fuel per 100 kilometer. That means 100 liter fuel of 1000 kilometer. That means 100 liter, it's 100%. 1 liter, it's 1%. And when we speak about of 0.5% of oil consumption, they needed 0.5 liter oil. And this is when we see this, it's a lot of oil, but the manufacturers say this can be normal. When we show this on the off-highway engines or on the truck applications, they say 0.1 to 0.5%. There was before also by MAN 0.1 to 0.5%, but now they change it and say 0.1 to 0.75%. It goes a little bit higher. In the calculation, you see truck engine on the road, maybe a little bit less, 35 liter of 100 kilometer, 40 liter of 100 kilometers, up to the application. A bus in the city need much more fuel than a truck on the highway. But we say 40 liter. That means 40 liter, it's 100%. 4 liter, it's 1%. And 0.5% oil consumption, it's 2 liter oil. 2 liter oil of this to the fuel. Yeah? And this is also a lot of oil. Some of them, they say this is too high. And also MAN say, okay, in the first 50,000 kilometer, when the engine is new, then can the oil consumption higher than 0.75% to the fuel. And then they must drop down. They say 50,000 kilometer. And this is also the running in effect in an engine. And this is up how they're using the engine in which condition. But I will show you later. Here you see that means 1.5 liter per 1,000 kilometer, and yeah, it's more or less, yeah, more than 6 liter per 1,000 kilometer. Or in this situation, this was not perfectly, and was we can speak about of oil consumption. On the technical documentation, and this is also, I think, your customer, when they speak about oil consumption, they will came with this letter, with this paper, and they give you exactly what they took in the last 1,000 kilometer, 8,000 kilometer or miles in this engine or in the fuel or oil. You see, first, the operation hours, the mileage, the fuel, when they fill the fuel inside, and also when they fill up oil in the engine. You will be happy when somebody came with this list, but this is not regularly. When you will check it and you will calculate it, the oil consumption, then you calculate it exactly with this list when you have it, then when you are happy, and then you say 5.85 liter oil of 996 liter fuel. And then we calculate it together, and then they say, or the calculation was completely, and say 0.59% oil consumption to the fuel. Normally we say 0.5%. It's normal, can be okay. In this situation, the oil consumption is too high. One question, is this enough to give to the customer the right information? Yes, this engine have oil consumption. Do you know how they use the engine exactly on the road, or what they done with the engine? Only with the calculation, with this calculation here, and when you make the evaluation. Do you know it? And you can say, yes, I will open again the engine, or you will discuss it more with the customer, or you have some question to the customer. When I stay in the workshop, I will have much more question to the customer. Here, one example. Which situation in case of higher oil consumption? You see first, A, this is a car with a trailer behind. B, this is a car maybe they is running very often in a big queue of cars. Maybe they drive in the morning in the city or out of the city and back and no more. C, they have a trailer behind with a lot of load. Or D, they runs in an engine, or they runs the engine in a very cold condition. What do you think? Which kind of car have a higher oil consumption? A, B, C, or D? This can be also two different.
B. It's B.
B?
Yeah.
In the situation, B, it's right, Mike, and also the position D. When we have a very slow driven condition, yeah, very less load on the engine, and also when the engine is running very often in cold condition and will be not very hot. This is a calculation also give me a signal, yeah, when I ask the customer in which condition you use your car. I drive only in the morning in the city and back at evening, and then maybe once or twice in the month I go with the car on the road on the highway, and we go a little bit far with this car. And this gives me also information. This engine, it's not running in very high load condition. The same example I will show you on the truck application. This was a calculation, a documentation, yeah, what your customer bring you every time to your garage. Yeah. The truck fuel is 35 liter per 100 kilometer with all the calculation. Then you see they have 2,940 liter fuel and 80.8 liter of oil. We make the calculation, yeah, the evaluation, and then 80.8 liter oil, 2,940 liter fuel, multiplication with 100, and say 0.64% oil consumption to the fuel. This was inside. In this maximum was the manufacturer say, yeah, but it's also a lot of oil. Here also, which situation of case higher oil consumption? The truck, they have wood sticks on it. This big tractor, maybe they have around about 150 horsepower with a wood cutting machine, very slow. C, a truck with a crane on it, maybe it's working on the road for road construction. Or this one, this machine, this is a wood cutting machine, and make this small pieces of wood that you can take in your house and you make fire with, and for the heating system. And they have also a crane on it. What do you think? Which truck have higher oil consumption? Or which situation? A, B, C, or D?
B, C, and D.
And D, Mark, you say?
Yeah.
B and C. This number B, yeah, this tractor have round about what I said, 150 horsepower. For this machine behind it, yeah, they need not more than 40, 50 horsepower. That's too much horsepower. This engine, it's saying, what do you want from me? Yeah, this is nothing. And also the number C, it's right, Mike. C, when the crane, you're using the crane on a truck, like this on this picture, it means this engine is running in idle speed and maybe a little bit more than an idle speed, but they don't need a full power of the engine for the hydraulic system to move the crane to left and right and up and down. You say also number D, Mike.
Yeah, because the wood chipper, yeah. Is it because it's wood chipper?
Yeah. The wood chipper, yeah, they need a lot of horsepower. This wood chipper, the most of the people, they don't know it, but I know it because I was worked before on this agriculture side. The wood chipper machine, when the wood chipper it's not working it's not working in high condition, they give with the CAN boost system to the engine, and say, or otherwise, when the engine say, I have much more load to make more, and this signal goes to the wood chipper machine, and the wood chipper machine say, okay, I will give more speed, give me more food inside. And then every time the engine is on the maximum load or the very close to the maximum load. And this is why the engine it's not running in idle speed. A and
So
D,
resistance again.
resistance, exactly. And B and C, this engine, it's running most in idle speed, or in this situation, what we see with the crane condition and also with this high horsepower, with this small machine behind. And this is why we can speak also when the load is not enough on the engine, then we can have oil consumption, or we can create oil consumption. This is also why I give you a workload. You see on the top, this is the how many kilowatt have the engine. This is an engine, a 7.8 liter. This is an engine that it's using by Deutz. It's a Deutz engine, TTCD. And then you see the torque load in Newton meter on the bottom side, 0 to 100%. And then I have a question to you. Which workload in percent can result in higher oil consumption? The range of 0% or 100%? What do you think? How many percent of the load we must have on an engine? Then we have no oil consumption or we have oil consumption.
Greater the workload, the less the oil consumption.
When we have less load, we
More
have
load,
higher oil.
less consumption.
Exactly. And give me a number, 10%, 20%. Which percent give me a signal of the load? Then we have no oil consumption or we have oil consumption.
Over 75%, higher than 75.
Higher than 75% of the load, then we don't have oil consumption, Mike.
Yeah.
You say?
Yeah. Yes.
Okay. Other information for me?
I think it varies. I don't think there's a specific percentage. I think the greater the percentage, the less the oil consumption.
Okay. I will show you. When we have a load condition here, this load spectrum, in the lifetime, maybe 100 hour, the engine was run, and we have less than 25% of load using in this 100 hour of the engine life, then the oil consumption increase. When we have 25 to 30% of the load, then they drops down the oil consumption. They decrease. And the most of the engine are, I would say, or the salespeople, they sell engines with too much horsepower, with too much load, what they normally needed. And when the situation is on the field, maybe, and then we have less load in the lifetime. And then we are under 20 to 25% of the load. And then the oil consumption increase. And the most of the engine, it's running when it's perfectly, everything is perfectly, maybe 25 to 30% or more. Mike, when we speak about of the load condition in the life of 75%, then we have a very, I will say, we have an engine maybe in a train, or we have an engine maybe in a ship inside. But you will never find with a standard truck on the road with a load condition of 75%. You can ask maybe when you have somebody, they can read the ECU on the truck and they can see what is the load condition on the lifetime of this truck. And they will be not higher than 50%, definitely. I will show you, and this is also not only in the truck application, it's also in the passenger car. And the truck much more, because they have in some applications a lot of idle speed time, maybe construction machines, or engine there is on a truck, maybe for constructions, yeah, and so on. And this engine it's using often under 20 to 25%. When we have this situation, when we under this 20 to 25% of the load, we have a different pressure in the combustion side. You know it better than me. In idle speed, the combustion pressure is be less. When the engine in load condition, turbocharger, it's bring a lot of pressure inside in the combustion, then the combustion pressure it's much more higher. And this is also the situation. The piston ring, it's jumped because of the own tension to the surface of the cylinder liner. You see the red line. But this tension of the piston rings, it's not enough together with this oil film between the surface of the piston rings and also between the surface of the cylinder bore to sealing it. We need behind of the piston ring another pressure. They increase the pressure 10 times more and bring the pressure to the surface, to the cylinder bore. Together with this, I will say, with this oil between there. This is the same when we go back to the slide with this wheel and the water on the road. We need speed, and we need also a weight of the wheel. They have contact with the road. When the wheel or the wheel is so less with the weight, they have nothing contact with them, and we cannot move it. And this is the same. We need the pressure behind the piston rings, and the pressure comes from the combustion side, and the pressure is different up to the load. When we have a load less than 20-25% of the completely load of the engine, then the pressure is so less that the piston ring tension together with the combustion pressure, it's not enough to sealing it. And then we have the effect that oil jump up to the combustion side, and then we burn the oil. It's very easy to find out. You go with a truck or with a car the hill down, you decrease the gas pedal, and then the combustion pressure it's decrease. Decrease also the tension between the piston ring, and then you have blue smoke. When you go with this car and climb up down the hill, the combustion pressure increase also the pressure behind of the piston ring, more tension between piston ring and the oil and the surface of the cylinder bore, and a better sealing effect, and no blue smoke behind it. And this is the completely easiest way that you can explain to the customer. And this is why it's so important in which condition they use it. And maybe when you can read it, the ECU, in which condition they drove it, then it's very easy. MAN, Deutz, first they look in the ECU and say, okay, you're using this engine in this load condition. Sorry, we cannot accept any oil consumption. And MAN, they give exactly in the workshop manual, or also in the workshop manual, they say exactly, or in the calculation of the service information about of oil consumption, when the engine is driven in less condition, under 20-25%, the oil consumption is not accepted. And I have a lot of phone call also from the OE side, from MAN and so on, and they drive in some conditions less than 20-25%. And why? They have a too big engine inside. They have a 700 horsepower engine inside, drove on the road without any hills, yeah, have a fuel consumption maybe of 25 liter, yeah, and then they have a lot of oil consumption. Here you see again over 25-30% of the load, higher combustion pressure, better seal on the scrubber function, and also they sealing and scrap the oil. This oil, what they don't need it for this typology effect. When we under 20-25% of load, we have lower combustion pressure, less seal, and scrubber function. Any question up to here?
Doesn't appear to be. Well, I don't know.
No. Then I hope
Obviously
everybody
very good.
understands it.
Yeah.
Okay. Cases of the influence of the higher oil consumption. You know it better, you see it often than me. You see the carbon on the piston, on the crown of the piston, on the first ring area. And this is not new, this is very old. The carbon is very hard, and polish the cylinder bore, and also polish this honing marks inside. And this is what I said before also, we need also a rough area on the cylinder bore. There are the oil can be clamped on it, and when it's missing, the oil drops down. And this is the quick effect. When we have carbon built up on the top, they polish the cylinder bore. I have one question. Why is there carbon on there? Why it's carbon on the top of the piston, or when they build up the carbon?
Collection of oil and fuel that's been burnt?
Not the fuel, the oil it's burned. When oil come up to the piston rings and come in the combustion side, and then the fuel it's burning, and then burning also the oil. And when oil it's burned, then we have built up the carbon. And this is exactly the situation when they use an engine in a wrong condition, and the oil jumped up to the combustion, the oil it's burned, build up the carbon, and then we have also this polishing effect. And this is the most problem on the field. Much more carbon built up on an engine with a steel piston, because a steel piston, it's a temperature much more higher than an aluminum piston, and the oil it's burning quicker and build up more carbon when oil it's come inside in the combustion side. This is also why we have on the steel piston applications special liner inside with this scrappering on the top to scrap the carbon up. Or maybe when you see this kind of engine, you see the pipe is completely broken from the air filter, or look, this air filter maybe from a construction machine, or the engine it's working in very, very bad condition, or also you see this tractor, it's working on the field with a lot of dirt. And definitely when they don't change and don't clean the air filter, or look that they filter the air perfectly, and the dirt it's coming inside, they also bring a lot of wear on the piston rings and the piston ring groove. And also when the piston ring and the piston ring groove have a lot of wear, they moved in situations they cannot sealing perfectly. And this is also one of the biggest problem, dirt inside in an engine when they don't look exactly in which interval they must clean or change the filter. But clean or change You see on the right side in the slide, find the videos of YouTube. That's a video, and then we describe in this video what it's possible to clean a filter, to knock it on the floor, to blow it out with a high pressure air blowing system, or you change it. Huh? In this video, you see what you make right or wrong. Also, a piston ring wear due to the wrong piston protrusion. I was in this company by Caterpillar. There I saw an engine. There was a damage, and then they asked them when they overhaul it, you check the piston protrusion? And they say, for what? I said, you must check it. You must check the piston protrusion. When the piston protrusion is not in the right condition, what the I would say the manufacturers say, they can be knocking on the cylinder head or on the valve. I never check it. It was Caterpillar workshop. You must check it. When you don't do it and the piston is knocking on the head, then the piston ring have vibrations, yeah? And then they don't have the right contact. This is also when the suspension of the wheel, yeah, it perfectly, the wheel is jumping up and down on the road. And then sometimes you have water between, sometimes you have contact, but you have not the right condition what you needed to move the car in this situation. And this is also a big problem when the piston is knocking on the head. Also, when they knocking on the head, maybe and the piston ring have a special ring inside, a molybdenum ring, or a chrome ring. The chrome and the molybdenum, they can break out, and then the piston ring cannot not sealing anymore anything. And this is why it's very important to check the piston protrusion. The next situation can be also bring a lot of high oil consumption. You see, the special people, they work in a very good condition. Maybe it's summer, then it's good, it's a lot of water there. But this engine was maybe runs before and then they stopped because they was water inside in the combustion side. You see it also on the right side, the oil with water, it's contaminated. And what is the effect? A bending conrod. And when the conrod is bending, this is very high bending. But when it's not in the condition what we normally needed, then the piston it's moving not in the perfectly line of the bore. They have maybe 5, 6, 10 degrees in an angle, moving up and down. And when they're moving up and down in this situation, the piston ring can be not turned in the ring groove. And when they don't turn in the ring groove, the piston rings, then the piston rings have wear on this side. There are on the shaft side, here in the front, on the back side of the piston. And then you see on the right side, left and right, we have a lot of wear. And then on the open end, we have no wear. And also on 6 o'clock, we have no wear. And when the piston ring are not round, they cannot sealing. And when they cannot sealing, oil jumped up to the combustion side. We have a lot of blow by, and also oil goes in the combustion side and build up the carbon, and then the story starts again. You see it also when a conrod it's bending or something it's wrong, that the piston runs perfectly in line of the bore, then you see on the piston itself this marks, and then you must check the conrod. Sometimes the customer, they don't say exactly what was before this fault was in the engine. Other point can be the task of the responsibility of the cooling circuit. When the engine is cold, you remember this slide, this car was staying in the snow, and every time when you start the engine in the cold condition and you bring the engine very quick in this, I would say, warm condition, where the engine is running in normal situation, then the piston, it's not in the line of the bore. In the cold condition, the piston, it's not round. See the left side on the slide. But a piston in the operation temperature, the piston is in the bore. It's round and it's perfectly to seal with the piston rings the combustion side to the bottom of the engine. And this is also when an engine, it's every time starting in a cold condition and bring it not very quick in the hot position or in this operation temperature, then the piston it's running along, looks like on the left side. This is also why we have that we don't have a lot of blow-by and also less oil consumption. Other point can be also higher oil consumption. The oil consumption is coming from the turbocharger, worn plain bearing. When the bearing on the turbocharger are not correct, and bring oil inside in the turbocharger, and then the turbocharger suck the oil and bring the oil to the combustion side. This is also a big problem with the engine with start-stop system. When they stop the engine, when the turbocharger is very hot, they burn the oil on the wheel, on the bearing side, and then we have a lot of wear because of the carbon that was building up there. And this is also why in the manuals they, please, when you come from the highway or when the engine was before in very high load condition, please let run the engine maybe 5 minutes in idle speed, that cool down the oil, and then stop it, and also cool down the turbocharger. Everybody do it outside. Sometimes. On Sunday, I don't know, but not often. Also, the crankcase ventilation. When the crankcase ventilation was blocked, the pressure in the crankcase can be too high, and also in this situation they can be not go back the oil on the oil drainage from the oil seal from the scrubbering. The oil scrubbering cannot drop back to the bottom of the engine because when the pressure is too high on the crankcase side. This is also some of the truck, say Volvo, I know it, they say every second or third service, they must change this crankcase ventilation valve. That be sure the pressure will be not too high. Also, oil consumption due to the valve steam sealing and the valve steam guide. When it's very hard, this is a rubber material. When they will be hot every time, they will be harder in the lifetime, and also in this situation, they cannot sealing perfectly. Damaged valve steam sealing or oversized valve guide clearance, wear on the valve steam sealing, and also the rubber, maybe it's something wrong. This can be also effects for higher oil consumption. Question up to here.
Rainer, no questions. You're clearly very good at explaining things.
Okay. The next, installation and possibly errors. This is, I think, also very important for you in the workshop on the reconditioner side. First, when you overhaul an engine, you must, some case when you have put an oversized piston inside, then you drill it out, you make a bigger hole inside to the oversize, and also you hone this area out, and then you are properly manufacturing hone surface. You see this must be, the angle must be right, the roughly must be right, and so on the application here on the gray cast iron cylinder bore. One example. This is also what we will speak on 14. What is it? 14? Yeah, of September.
Saturday the 14th. Yeah.
14. Yeah. We will have a seminar in the 14 in UK about of the honing process.
A live face-to-face. Live.
Face, exactly. Yeah.
And the practice.
And the praxis also, yeah. But we don't have a honing machine, yeah.
No.
But we have a lot of examples with us. You see, we need the scratching marks, and the scratching marks, what I said before, this have also a clamping effect for the oil, and also the oil can drop down to the oil pan in this groove. And this is important that these scratching marks from the honing process will be a completely line, and they will not stop between and start at another point. When this will be not right, the oil can be not dropped down to the oil pan, and then also we have too much oil on the surface, and then oil comes also back to the combustion site. And this is why we need the right honing process. And some of the people outside in smaller garage, I will not say the reconditioner, but small garages, they don't have a honing machine. They go inside with this brushing tool or with this honing process tool on the right side. But in these cases, they will not make the right scratching marks for the honing process what we needed. You see it on this picture. On the right side, this will be perfect. On the left side, you see nothing. Yeah? You see a completely damaged surface. You see a little bit a scratching mark here. Yeah? Wait 1 second. Yeah? I will take laser pointer. You see it here. Here you see a scratching mark, but here it is broken. The oil can be not jumped completely down. Here you see a scratching mark. Here stopping. Here also scratching mark, stop, stop. And the oil cannot be dropped down. On the right side, you see it's completely one line open. And this is the effect what you take it with these tools, yeah, when they're using these tools in the workshop. And this is why I say this have nothing to do to overhaul the engine. They can try it, but they will come to you definitely for overhaul this engine in the correct wise with the honing machine. In some cases, when you don't adjust the honing machine correctly, then you will not cutting the area of the surface, then you're bending the area. When the stones are not sharp enough, when the pressure is too high, when the speed are not correct, when the oil what is using in the honing machine are old, maybe when you have a lot of particle inside in the oil, then they will not be cutting perfectly, then you're bending the surface, and you see it on the left side, it's bending completely down, yeah? And then when the piston ring it's coming up and down, yeah? I think you know it what's happened with the piston ring. They have a lot of wear. They come and say, I have a lot of oil consumption. You say maybe, okay, drive it maybe 10,000 kilometer or mileage more, and then we will calculate it again. And then the oil consumption increase much more because the wear on the piston ring is so high that the piston ring is completely damaged. The first, the second, and also the scrapper ring, the oil scrapper ring. And then you open the engine and you see the scrapper ring are completely damaged. And then normally sometimes, I know it from different places in the world, they say the piston ring from this company are not perfectly they are the very bad part, and then they change it from another company, and they bring a new piston ring inside in this engine, and then the oil consumption it's less. Yes, will be less because the piston ring was before runs on this bad surface. They maybe bring the surface of the bore, there was the bending area, a little bit in the normal condition, but the wear was so high on the piston rings. And when you change it to a new generation of piston rings, the piston ring find a better surface, and then the oil consumption is less. Have nothing to do with the quality of the piston rings, have something to do how good was the quality of the repairing of the surface. This is also, we need in the surface of on the gray cast engine block, this graphite fines, this small, yeah, I would say pipes inside in the surface in the gray cast inside, that the oil can be moved inside in this line. On the left side, you see there is no open line. The line is every time broken, and they have no directly open contact on the end of the surface. And this is also very bad for maybe when we have less oil in 1 second, the oil can go out of these graphite lines and can be moving in a very short time with less oil on it. And this is why we must cutting in this honing process, cutting open these graphite lines. Some of the people in the workshop, they don't know exactly how they install the piston rings, and they bending too much. They break out maybe the molybdenum or the chrome is broken, or the bending distortion you see on the left side, and then the piston ring cannot move in the ring groove. When they don't move it, they're not turning around, then we have left and right wear, and then we have not a round piston ring, and the piston ring cannot sealing. One other effect, when they open an engine and then you see the wear on the top dead center, this is what I described it before. When the piston runs up and down, they have speed. Remember this wheel on the road with the water on the road. And when you stop the car, the wheel have contact with the road because we are missing the speed. And exactly in this situation, when the piston on the top dead center, the piston is stopped for 1 microsecond. And in this situation, we have a very high pressure behind the piston ring from the combustion side. When the fuel is burned, the piston ring is jumped out with a very high pressure. The oil between the piston ring and the surface, it's moving, and the piston ring have directly contact with the surface. And this is why we have on the top dead center, on this area, the piston ring, it's turned from top to down. We have a lot of wear. You see a 0.1 millimeter on the passenger car, it's a calculation, then will be a problem. And the heavy duty 0.15, bigger of them, then we have also speak about of oil consumption. I saw one of them in my life engine, they have the wear was on one side 1 millimeter. They have a lot of blow-by. This engine was not running perfectly, and this is why they open it. 1 millimeter left and 1 millimeter on the right side. That's 2 millimeter of the diameter of wear in this area. There was a lot of dirt inside and other things, and this is why we have this big wear on the top. When you don't measure it and you say, okay, this is not so much, you have this situation, an old engine on the left side, the piston with the worn piston with the worn cylinder bore, and you see the piston ring can be moved a little bit up to this point. There is the wear on the surface of the cylinder liner. When you only change the piston and the piston rings, and you don't change or overhaul the bore, then the piston ring, it's contact directly on the situation on this angle. And then the piston ring, it's jumped up and down and have a lot of vibration. And when they have vibration, they cannot sealing. And then in this situation, when you only change the piston with piston rings and don't check the liner perfectly, and the piston ring, it's jumped on this angle on it, then they increase the oil consumption. One recondition, they called me and asked me, Rainer, what do you think? What is happened? Because the oil consumption is increased. But I change only the piston and the piston rings. And I asked them, do you check the cylinder bore? Yes, I had a little bit wear on it, but I think was okay. I said, what do you want? What do you want to hear from my side? I know it. It was my fault, Rainer. I said, yes, this is right, exactly. This was your fault. You must be changed again, open again the engine. You must change or overhaul the cylinder bore to oversize. Yes, this is right. I think was not so critical, but now I know it. Also, in the last point, it's very necessary. The most of the people, they think about it when I overhaul an engine. It's better to go slowly this engine, step for step, to a higher load. No, this is not okay. And also a lot of people, they say, I will stay the engine outside of the garage, drive or runs in idle speed, maybe on this cleaning washing area for half day or 1 day. No, this is also not good, because exactly on this situation, when you don't have load on the engine, we have two effects. The first effect is all these components, the surface of the bore, the piston ring, the piston, they must marry together. And this married together situation will be quicker when you have much more load on it. And then they have a perfectly sealing condition, especially in the piston rings. When they move it, when they have the pressure behind it, then they moving around on the piston ring groove, and then they will be perfectly sealing the combustion to the bottom of the oil pan. The next effect is when you drive the engine in idle speed. You have not this running in effect so quickly. And the other effect is they sealing not perfectly the combustion side to the bottom side, and then oil come to the combustion and build up or burn this oil and build up the carbon. And when we build up the carbon, we polish the cylinder bore, and also in bigger situation with a higher carbon on the piston ring or on the piston ring groove, the piston ring cannot move in the piston ring groove. And then they stick, and then also they have wear. And this is why every time I say, don't use this engine first in very low condition. Use the engine how good you can do it. When you know it, the customer I will say, do it very slowly, and you have a test bench, you can run the engine in, then do it in your office or in your garage. This is also why we write service information, lubrication at a part of the load, and full load lubrication during excessive idling. It means in idling is not possible, and you can find it also in English version, the service information SI0026. And this is also what I say, print it out, give it to the customer, say, don't do it and use the engine in idle speed, bring it under load, not on maximum, but 60% of load in normal condition, what we will say. And then the engine will be run in effect perfectly, and they will not have oil consumption as soon maybe of an engine there was before runs in idle speed.